Because according to this code here, it does not specify what would be the initial value of f. Okay, in this case, it would be 1, assuming the loop is a post-checking loop. So in revision 4, we have to say the first prime or the first factor to try is f equals 2. Okay, I'll just write that much first, and then I'll just copy this code. Because if the loop is incrementing, if f is not a factor, I should start with 2. So now the next question is, should I use a pre-checking loop or a post-checking loop? This time it is a trick question. We can use either. Okay, the answer is we can use either. The problem with this is, since we know the first number we want to try in the mod operation is 2, we can make this post-checking by initializing f to 1, just like what you said. Okay? Or we can make it a pre-checking loop and have f initialized to 2. So I will give you these two solutions. So in revision 5a, we have f gets initialized to 1, and then we say repeat f gets f plus 1 until n mod f equals to 0. That's revision 5a. Revision 5b is saying f gets initialized to 2, and then we say while n mod f does not equal to 0, do f gets f plus 1, and while. And now I can tell you right away that f5a and 5b are equivalent. They're basically exactly the same. They are both correct. Which one do you think is better? And why do you think it's better? In terms of the number of lines of code, they're exactly the same also. So there's no advantage either way in terms of length of the program, but there is a difference in terms of the clarity of the algorithm. Yeah. Now, from the programmatic perspective, the first one does have a slight advantage. Once you guys, if you move on to CISP 310 in assembly language programming, you can see that this code is actually slightly more optimized. It goes a little bit faster. But in this class, we don't deal with that. In this class, we look at the clarity of the code. In other words, if you just look at this code here, can you easily tell what is the first number that I will try to mod n with? It is not very clear, is it? Because we know this is going to be 2 by the time we get here, but only because f is initialized to 1, and this is a post-checking loop, we have to add 1 to f before we get to the condition of the loop. Okay? So you need to read 2 lines at least. You need to read the initialization and also the body of the loop in order to figure out what is the first number we'll try. In the second version, it is much easier because the conditional statement is right after the initialization of f, and this is a pre-checking loop, which means it is very clear to us that the first number we will try to divide n by is 2. Are we okay in this case? That makes the second version better for people. To the computer, it is the same. It is identical in terms of what they do. But to people, the second version is better because it is easier to understand what is the first n that we'll use when we try to find a prime factor. Okay? So we'll probably just go ahead and stop here today and try to read ahead of me. Okay? On Wednesday, we'll basically finish up top-down design. And I'll tell you guys a quick trick too. If I give you a really huge number to test, in order to determine the number itself is prime, you only have to test numbers up to the square root of the number. Okay? Now, it makes sense to most people, but can you prove that that is the case? So on Wednesday, we'll do the proof, which is not in the class notes, and we'll do it in the class instead. Remember to save.